Okay, let me start today's session. And in today's session, I'm going to discuss two parts. First of all, in data analytics, we can discuss the basics types of learning that we can talk about and the basic concepts that you should understand before you start any data analytics part. And finally, I will discuss how to prepare the input. So those are the things that I'm planning to start with. So having said that, you know that any data analytics environment, simply we can talk about four basic types. First one we call classification learning, or in other words, we say supervised learning. So in this, what will happen? Usually you are trying to predict a particular value. Usually it will be discrete. For example, we are going to see a weather data set. I think I showed you last time in the lab session, where we are going to decide whether to play or not based on different weather conditions. So this kind of problem we known as classification problem. Another simple example would be classifying images, whether image in an image, whether you have a cat or a dog. So ideally, given an image, if you can decide whether you have a cat or a dog, could be a classification problem. So that is what frequently used, data analytics problem that we can talk about. Second one, rather than you look for a particular class or a particular attribute to decide, you can look at only associations. Now, this is useful for places where, for example, classical association learning problem is called market basket analysis problem. So which means if you go shopping, as a shop owner, you would like to know what customers will purchase together. For example, in the US, they have done a study to see what customers they were purchasing together, and they were noticed in some place where people purchase diapers with beers. Now, if you ask me like why this is interesting problem, okay, in a way you can use this information to arrange their flows so that customers can purchase things easily. The things go hand in hand. Or else if a particular customer purchases one of the items based on the historical data, you can suggest other customers to purchase the other item. So that is also another interesting outcome if you use association learning. Third one, we call clustering or unsupervised learning. In this problem, you don't really need, focus on a particular customer or class. You just look at some relations among the data set. For example, if I'm in a class, I normally see that my students sit in kind of a pattern. The friends used to sit together. Likewise, you see different groups in a class. So in some way, they are similar to each other. That's why they sit together. Similarly, you can use the same idea for customers in an organization. Organizations are interested in learning what customer groups in their data. So this is very, very important to figure out things. So simply what happens during the clustering or unsupervised learning, you don't have a attribute called class attribute, but you use all the attributes together to find similar groupings in the data. Final one we call numeric prediction. Now in our first problem, in a classification you're learning, you usually predict a one particular class. In weather problem, we decide or we want to know whether we are going to play the game or not. So play, is it yes or no is the question to need to predict. So that is a categorical value. But the numeric prediction is just the number that we are interested to predict. For example, CPU performance. Given a set of configurations, we want to find out what the CPU performance is. So this time it will be a numerical quantity. So same goes with, for example, financial markets, for example. So market value or predicting market value with high accuracy is very, very important, right? So that comes under the numeric prediction problem. So these are the 4 basic types of learning that we can discuss. Right. So let's formally discuss each of these problem types. So in classification learning, as an example, what I have given to you is predicting whether to play or not play. This is known as supervised learning. So how we are going to start the learning process is you collect the data with actual label. So that means when you collect the data, you collect all the weather conditions together with whether that game has played or not. So together we can create a training set for classification. But then again, whether this is success or not based on the rest data, which is the data you have not used for training, right? We can also say that it's test data, or you can say it's a fresh data, right? The second one, association learning, like I said in supermarket basket analysis, what items are brought together is the interesting point that we want to highlight. So no class is specified, but we can look for any interesting structures. If you compare this with our previous classification learning, always classification learning predict one particular attribute, right? So therefore, when you calculate attribute values, so it's not just the class, you can look at any attribute combination. So therefore, usually you get large number of association rules compared to classification rules. So you need to have a restriction or constraint for this. Usually we will use minimum coverage. That means the minimum number of attributes, instances are covered here. And also the accuracy. So these are the 2 measurements usually talk about. In clustering, example I have already told you is customer groupings. So we can find groups of items in a similar fashion. This is also known as unsupervised because we really don't know what the class value is, or we don't get an attribute as a class here. Then, therefore, the outcome or the success of this is very subjective. So we can say success of all measured subjectively. So then the last one we call numeric prediction. In numeric prediction, instead of a class, actually this should be class, not bindi, or this should be play time. So the number represent how many minutes, for example, they can play, right? So schema is being provided with the large with target value. And then again, measurement for success is based on the test data. Right. Now that we have understood the 4 basic types, let's talk about some basic understanding about the data analytics. The first one is we are going to talk about what we call concepts, right? So any problem that we have discussed, the 4 basic type, what we are trying to learn is some kind of a concept. Simply, you can say that thing to be learned. So the description you get for the concept, we call it concept description, is the outcome of the learning algorithm. So which means we are going to talk about some learning algorithms in coming sessions. For example, it could be something like a rule set or a decision tree. So which actually describe your concept. Success rate on test data. So remember, in the process of developing these algorithms, you have to divide your data as training and testing. So success rate on test data is used to recognize how well the concept has been learned, right? So that's what basically we talk about. For example, separating cats and dogs, we want to know like what separates cats from dogs. Right, then the instances. So you can record specific instances. So these instances can be classified, associated, or clustered. And sometimes you have a set of attribute which defines the instance. In other words, it could be a single row in a database table, right? So usually, if you have multiple data points or data sets, usually we will have a merge relation. You put everything into one single relation, which we call flat file. You know that in databases, before I proceed, let me. Okay, so any data that you want to usually, analyze, we have to start as a single, what we call a flat file or a single table. So in databases, usually, especially in relation databases, we separate the data into several tables. And whenever you need it, you combine them, right? But when it comes to analytics, usually it preferred one single table. So therefore, when you separate the data in normalization, you have to actually merge them. You have to combine them. We call denormalization. So you put into one single set, right? So then there might be some issues that you have to face if you do this. So you have to be very careful about the fake regularities. Right. So having said that, let's move. So now we understood what a concept is. And then next we'll look at what attributes are. So usually any instances you will take, that means if you take one row of a record, so you have a set of features which we call attributes. So in our previous problem with the data set, we have outlook, then we have temperature, windy, and so on. So we have several features which we'll use. So they are the ones we call attributes. So this number might be vary. Sometimes we might not use all the attributes. Some might be not relevant. So the problem is existence of attribute may depend on one another. For example, spouse name, we can talk about if person is based on married or not. And then we can talk about possible attribute types. Now, before we move on, we want to know different types of attributes. So commonly used attributes, you have different values we call distinct symbols. So if you have attributes or the labels, separate ones, then we can take them as they are distinct values. For example, in our weather data set, we had an attribute called outlook, and you have different values. So, for example, in Outlook, we can have three different values like sunny, overcast, rainy. Temperature, we can have high, low, cool, and so on. So, windy, we can say true and false. So, similar that you can have different set of values. So, there's no relations. Usually, we talk about when you say nominal. That means there could be no order, no relationship. So therefore, when you compare two different records, you have to compare with equality. Right. The next type we call ordinal. Remember the previous one we said there's no order. When you say outlook is overcast, sunny and rainy, you can really compare. But for example, if you take our second attribute, in second attribute, we have three different values where we have hot, mild, and cool. Actually, you can talk about a relation with these three attributes. Right. Now, when you talk about these relations, then we can't talk about any arithmetic operations. But then you can have comparison operators. Like, for example, if the temperature is less than hot, we can say you can play the game, right? But it's very difficult sometimes, separating out this from various different categorical value, right? So therefore, depending on your requirement, you are going to decide on which category each of these attributes are. Similar to that, the third type we can talk about, we call interval quantities. So that means you can define different values. Now, for example, if you take temperature, you can express in degrees Fahrenheit. So, for example, you can talk about the difference between the two different values like 46 Fahrenheit or 48 Fahrenheit. So you can make a difference. But if you take a year, for example, right, the difference between the years might not have the same issue. So getting the difference might be very depending on what attributes we are going to use. So for example, if we use the difference, it might make sense in both cases. 48 degree Fahrenheit and 48 degree Fahrenheit. You can talk about difference. Years 1939 to 45, again, you can think about the difference. But what about the summation? If you sum up, then you don't have any meaning for, especially if you take adding 2 years, doesn't mean it at all. For example, at the same time, if you think about the 0 point, right, for a year, right, it's not defined. Okay. So these are the things that you need to consider when you talk about the attributes. Last one we call ratio quantities. Then in ratio quantity, usually we can talk about the 0 point, right? For example, if you talk about the distance, if you calculate the distance between the object and particular object and itself, we can say it's 0. So we can treat them these as real numbers, which means you can use all the mathematical operations, not like in previous case. Okay. Next. Now, although we talk about the 4 different types here, most frequently used is 2 levels. Usually in, many analytics, we use nominal and ordinal data types. So nominal in the sense, different, categorical variables. Similar to ordinal type, we can say numeric or continuous, right? So these are the 2 types that we can actually talk about when it comes to commonly used attributes in practice. So now let's talk about how to prepare our data. So the idea is we can use different data sources. So usually data will come in different places, maybe them as different database tables, or sometimes it could be several sheets, or you have a combination of these. So what are the differences? So the differences, for example, how they record conversions, time periods, data aggregations, primary keys, and any errors. So various different management tasks are used: assembling, integrating, cleaning up data. So usually about 80% of the data, 80% of the time, you should focus on the preparation of the input. So nowadays we talk about data warehouse or data lakes to handle this one. The recently people use the term data lake to represent that you can store the data in any other format. So what you need to consider is denormalize them. That is especially relational databases if you see a gap. And then you might need extra cost. So the problematic part we call critical factor could be the type and level of data aggregation. So that's what you need to careful. Okay, now that we talk about the basics, let's start with a problem. I hope you are already familiar with the weather data set. So in this one, let's talk about how we can convert this so that we can actually use it, right? Right. So the first one is, let me show you how to create data set given some instances, right? So I hope everybody is working with the Veka. So I will first talk about how we can represent this and open up in Veka, right? So the first thing is take a notepad. Right, can you open up a notebook and type these together with me? we'll say at relation weather. So that means we provided the value for this. Then you have to go through each an attribute. We'll say at attribute. Then the name of the attribute, we'll say Outlook. And then we list what are the values possible. We say sunny, rainy, so we can have sunny, rainy, sunny, we can say overcast, so similar to that, you can update this with other types, and finally you will have class. Again, you can do as a attribute, so we will say data. Values we can sunny, hot, IGH. So we have sunny, hot, high, and we have false together with the class label. Okay, this is how you should type. Right. Can you finish this and share me your answer in the chat? So what we are going to do is we are actually going to convert this table information into open in a Veka toolkit. Now to open in a Veka toolkit, we have to convert this tabular information into the format, which we call ARFF format. So for example, the first one is we talk about the relation weather, that is the whole data set is called weather. And then we list each attribute. So the first thing I did, I used at attribute Outlook, and then I list all the three different values. We have sunny, overcast, and rainy. So similar to that, if I say temperature, I can say attribute temperature, and then I can list the values. Right? So that's the idea that we want to have. Then we have high and normal humidity. So we can say attribute high, oh sorry, humidity. Then windy. And then we will say attribute play. We say yes or no. So we have listed all the attributes now. And then you have to finally put the data in this form. So right now, let me just save this. I will put in the desktop. And then I will say this is my weather .arf colon. So your file name should be enclosed with double quotes. Okay, I have put only one data point, but then let's open up Weka. Okay, I open this Vika 3.8. We go to Explorer. And under that, we'll go to open file. You go to where you have saved the file. In our case, we put in the desktop, my weather, click open. So this is what we have. Okay, so that's what we need to do. You have to type all the records in this form. Right now, I have included only one, but there are many others, but I want you to finish up to this point and raise your hands. So let me put the data points into this. So what I'm going to do, I'm going to resize this so that I can read everything. Okay. Sunny, hot, high, true. Sunny, hot, high. We have false, no. Right? So let me type everything. We have sunny, hot, high, true, no. Overcast. We have hot, high, false. Right, we have done this. It is a data set. So let me open now. Let me open. So we have a bit of a problem. Line 20, there's a problem. Okay, so there's a problem here. I forgot quotes. Line 20 again, another issue. So this also should be yes in single quote. Okay, still there are some errors. Nothing wrong I can find. Let me.
Sir.
So let's say you have a CSV file like this. So CSV file usually you have labels like this, and then you have a set of attributes. So let me say Outlook, temperature, then third one we have humidity, and the next one is windy, and then we have play. Right, let me save this as a CSV file, save as. I will also use desktop. Let me use in double quotes CSV, my weather CSV. So this is how usually CSV file looks like. And let's try to open this with here. So I'm going to say open. I'm going to use CSV. Okay, we have my weather. I will click open. Okay. Okay, let me check. Again, there's a small issue. Okay, so I forgot this. Hopefully this is okay. File save. Okay, so let's open up my weather, open. Index 5 out of ball length 5 problem. Okay. Again, there's another issue. So we have outlook, temperature, humidity, windy, and play, sunny, hot. Right? Okay. What was the error? In this part, we are going to talk about the basic machine learning algorithms. The basic ideas, I'm not going to go into detail, but then I will also show you how we can implement using Weka. So the first one is when you're given data set, you can just look at the class variable and then you can use the majority. So likewise, we can have very simple algorithm in machine learning. So therefore, when we want to work with data analytics, especially in choosing machine learning algorithms, you can always start with the simple algorithms. And there are many simple algorithms like use of only one attribute, use of all attributes, and so on, which I'm going to select one or two structures to explain this idea. And then whether this is a successful, it's actually totally depend on the domain, right? So that is what you need to practice. So the first one is what we call the 0R. 0R means you learn the majority class. So let me explain. If you take your Weka outcome, so let me start with Weka here. So this is my Weka and this is the Explorer. So I'm going to use my data set. So which is ARFF first. Okay, and I open up. If you click edit, you can see my data set. So this is the data set I have. Right. Now 0R means you look at the frequency in here. For example, if you look at this column, you can notice that there are 9 yes instances and 5 no instances. So the therefore is, this is yes, right? You can be random, but then accuracy will be 50%, but here you will get a very high accuracy. Right. So how do you do that? You go to classify, you select 0R here, it's a default, and you click start. And you can notice, forget about the numbers for the time being. You can say that 0R predicts class value as yes. Right? So that's what we call 0R, which is focus on majority class. Okay, so let's move to the second algorithm, which we call 1R. So 1R is usually we call single level decision tree. You can actually think that one depth is enough, one length is enough. So how it works? Usually you go through each and every attribute at a time and you take an attribute, for example, Outlook, we have 3 branches, sunny, rainy, and overcast. Each of these, you have to look with the class label. And then you use the frequent value to make a rule. Right? And by repeating that, you can work on all the attributes and then you come up with the zero algorithm. Right. So here is how it works. Usually you start with each and every attribute. For attribute value, you create rule. You create count how many times the class appears. Find the most frequent data, make the rule assign that was close to this attribute value. So this is our example. So now what I want you to do is focus on this part. So focus on sunny and then look at the class variable. You just know. So in this one, we are going to look at how we can generate 1R algorithm. So in 1R, you have to go through each and every attribute. For example, in our case, we selected Outlook. We have 3 different values. So you are going to make a rule with most frequent value. So when I say Outlook is sunny, the most frequent class for sunny is, we have 3 no's and 2 yeses. So this should be classified as no. What is error? then there are two instances, 2 divided by 5. Similar to that, look at overcast. Every time when you look at overcast, together with the class label, overcast, class label, overcast, overcast, yes and yes. So what you can notice is we can now overcast when you say overcast, it's always yes, right? We say that it's classified as yes. So how many times we have 4 out of 4? There's no errors. Error is 0 divided by 4. No errors. Then similar to that, rainy, we have yes, yes, no, yes. We have yes here. So rainy is yes, but then again rainy yes, yes, no, yes. So in rainy, for example, in here we can say rainy yes, rainy yes, rainy no, rainy yes, rainy no. So that means we have 3, 4, 5. So there are 2 misclassification divided by 5. So this is what we have. The total error, if you combine these two, 4 divided by 40. So that's what we have done for this. Okay, similar to this one, small homework. Find the values for temperature. Find the values for temperature. Similar to that, if you do, let's say, for temperature, we have hot, we have mild, we have cool. So for hot, for example, we have no, no, hot again, no, hot again, yes. If you go down here, we have one hot here, that is yes. So no, no, yes, yes. That is what we have, right? So what it means? Any ideas what it means? You can either use no or yes, right? Because it's same. So let me put this as, for the time being, which put as no. I will put as no, but I will put a star to denote that this is 50-50. So the error is 2 out of 4. Temperature is mild. So what happens? When you say mild, just map. Here we have one mild. We have yes. Another mild. We have no. We have mild, mild, mild. We have 3 milds. We have 3 yeses. So which means when we have mild, so here is also mild. How many? 1, 2, 3, 4, 5, 6. Out of 6, we have yes, no, yes, yes, yes. No, the most frequent class is yes, right? What is error rate? We have one no here, another no here. Again, 2 divide by 1, 2, 3, 4, 5, 6. So this is 2 divided by 6. If it is school, let's say yes, no, yes, school, yes. So cool again, we have 3 yeses and 1 no. So 1 divided by 5. Sorry, there was a mistake here, right? What was a mistake? So this should be 4, right? We have cool, 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 yes, no, yes. We have yes, yes, no, yes. So that is 1 divided by 4, right? So that is the total is 5 divided by 40. Okay, that's how you should make the calculation. Okay, now let me show you my answers. So let me clear everything. So if you follow the same, you can see this is what we did. If you do this for all the 4 attributes, this is how it look like. For each attribute, we create each attribute for each attribute value, right? We calculate the errors and total errors. Okay, now when you actually work it out, you can see that the 4 attributes, the error rates are as follows. And then we have 2 candidates, 2 answers with lowest error rate. We can either use Outlook or a humidity. So idea is when you have a 2 candidate like this, you choose one. So in our case, we are going to select Outlook as the outcome. So it could be humidity as well. So now let me show you this in Wake Up. So in Wake Up, for example, if you want to perform the same thing, so let's open up Wake Up. So here is our data set. We have opened. Here is our data set. So we'll go to Classify tab. I'm going to open 1R, right? And if you perform 1R, I'm not going to change anything. I'm just going to click Start. If I click Start, now you can see we get this answer. Outlook sunny, no overcast, yes, and rain is yes. So this is the outcome of the 1R algorithm. Okay, so please do the same in your data set. So now, so far we had assumption. We worked with nominal data set. That means everything is categorical value. That means no numerical data sets were there. So if you have numeric data, what will happen to the algorithm? So that's what we are going to see. I'm going to briefly explain what happens, and then I will show you in Wake Up. So when you have a numeric attributes, what happens in this algorithm? Basically, you put into all the numerical values together with their class label. And then if there are any changes, then we make breakpoints. So the idea is we want to minimize the total error. For example, let's look at our temperature data set. So in this data set, you see temperature and humidity is the numeric data. So as I told you earlier, you sort this value together with the class label. If you do that, you can see whenever there's a change in class, we have to make a separate value. So therefore, what we do, we look at the values when there's a change in classes, we make a separation. So likewise, here also we make a separation. Here also we have separation. Here we cannot put a line because the values are the same. Therefore, we put the line here. Then again, we separate out intervals like this. Okay, here is the outcome. You have intervals. But the problem with this one, this is too many intervals. Therefore, what we do, right? What we do, we can simplify number of ranges. So O-fitting means usually you might get very high accuracy in the training, but very poor accuracy in the testing. So therefore, this also can happen here because you have too many separations. Therefore, we will put a minimum condition. So what do you mean by minimum? Okay, for example, the same thing, right? In earlier, we said any change, you will have separation. So it will be like this. But now we say there's a minimum value we are specifying. So start from here, you have 1 yes. That means you have to cut out this one, then cut out this one. You will see all these are classified as yes. Similar to that, if you take this, right, minimum should be 3, right? So no, no, yes, yes, yes. For example, this is also yes. This one, half and half. So therefore, we can put no, but I will put as far that it could be yes as well. So what happens if you do this, you remove intervals a lot. Right. Now the next one, what we do, this is also yes, this is also yes. Therefore, we can cut this one as well. So what happens from up to this point, this will be yes, and this will be no. So what you do is you get the middle value of this. The middle value of 75 and 80, that will be 77.5. So this is where we can create a rule. Right. Now we did it, we can move on. If you do the same calculation for temperature and humidity attributes using the interval from the previous step, here will be the outcome. So you will get total out for temperature is 5 out of 14, humidity is 3 out of 40. Okay, my last question is, what is the outcome? Is it outlook, is it temperature, is it humidity, or is it windy? Right. We can see that humidity gives you the least error. Therefore, the outcome is humidity. Right. Now, to conclude my session for today, let me show you this in Wake Up. So I'm going to open up a Wake Up. And I'm going to open up a new file. So if you go to C and program files and under Weka 3.8 whatever, I'm going to select 3.8.6 and we'll go to data. You go to data folder and you will see weather numeric dataset. Click on this. If you click on this, you will get a dataset like this. But if you look at temperature, it'll give you statistics because it's a numeric dataset. Same goes with the humidity. Now I go back and here we have to say 1 hour. Okay, now early I have not considered, but this B6 means how many values you are going to say basket size. So I will put this as 3 because that's what we have discussed early. Now let me start running. So if you do this, you will notice here, humidity is the outcome, right? So now I think I have showed you both nominal and numeric. And we discussed today two machine learning algorithms, 0R and 1R. Okay,